continuous random variables, working out the median. The median is the value taken by the continuous random variable which divides the area into two halves, or the probability into two halves. So for instance, if you have a look at this probability density function, the median, so the value that's there, divides the total area underneath the curve, and the total area underneath the curve is 1, but it divides it into two equal halves. So you've got half on this side and you've got half on this side. So you can use some simple integration and you can work out the value of the median, because you know what the area is equal to. It's a half. So we can either integrate from x equals a up to the median, like this, and we know that will give you a half, or we can integrate from the median up to the upper limit here, b, and that will give a half, like this. In simple examples like this, we know that we have a uniform probability distribution here, and the median will be exactly halfway between A and B by just looking at the symmetry in the graph here. So the median is a midpoint, and to work out the midpoint, if you add the two x values there together and then divide by 2. Okay, so the median is equal to a plus b divided by 2. Just like you work out the midpoint when you're looking at an example from coordinate geometry. In this example, to work out the median, we can either use integration, and this probability density function here is defined like this. There's our restricted domain, and the equation of that line there is just y equals 2x. So you can integrate 2x between 0 and m, or between m and 1, and the area is equal to a half. Or you can use some geometry, using the area of a triangle, for instance. Use the formula to work out the area of a triangle, and from there work out the median. Questions that typically say show that the median is equal to some given value, they're best approached by actually using this value and showing that the area you get is equal to a half. So for something like this, we could start off by saying, well, if I integrate from my lower limit here, which is 0, up to my median, which is root 2 over 2, this probability density function, I'll just call that g of x, and we know that because this value here is the median, the area and hence the probability should be exactly a half. So if you can show that by using this value you get a half, then that value has to be the median. This is an easier method than doing this, saying, well, here's my lower limit, which is 0. If I integrate from my lower limit up to the median there, and that will be equal to a half, and then to work out all of this, and then to work out the value of m. It's much easier to show that using that median value of root 2 over 2, it will give you a half. If you can prove that, it's okay.